More excited today to talk to you guys about how we at Cloud Posse have achieved unlimited staging environments on Kubernetes. That is how we can run complete fat stacks of fully disposable apps on Kubernetes for staging and development, and really nothing is holding us back from doing that on production as well. So to give you guys an overview of what to expect today, it's going to be about 30 minutes of me talking. I'm going to start off with my background, why I'm so excited about our solution and what drove us to come up with this solution, the what, why, and how of unlimited environments with lots of screenshots so you'll get a clear picture of exactly what it looks like. Then we'll roll the dice and do a live demo so you can see it in action, that it actually works. At the end, we'll give you links to all the tools. They're all open source. They're mostly on our GitHub or other public GitHub repos out there. At the end, we'll follow it up with a Q&A or ask me anything, and I'll be happy to answer. All right, so I was the first director of cloud architecture for CBS Interactive, and I cut my teeth on sites like TV.com, Metacritic.com, and Clicker.com. After spending some time at CBS Interactive for a few years, I ended up taking an extended sabbatical. I traveled the world for a couple of years and then came back and founded Cloud Posse. Right now, I couldn't be more excited about the tools available. When I started using Amazon, this was in 2006. My first startup, we were a very young startup that got into an early private beta of AWS. And at that time, there were no tools available to us. We had to build everything from scratch. It's a very different situation today. So at Cloud Posse, what we're really focused on are cloud migration. So helping companies move from platforms like Heroku onto Amazon using technology like Kubernetes. We can't deliver that solution if we didn't also have complex CI/CD pipelines and really smooth automated deployment processes. So that's why when a customer came to us and basically asked us, how can we rapidly spin up new environments from scratch in a matter of minutes, triggered simply by the push of a button or automatically for every pull request, we got really intrigued. We spent probably 2-3 months working on this demo to get it working, and this is because we wanted a lot of features in this. We knew we had to be able to deploy absolutely any branch or combination of branches because today's microservices are pretty complex. We also needed to have it fully integrated with CI/CD. So what we're really saying is we want an unlimited number of CI/CD pipelines, basically one CI/CD pipeline per environment. We also needed to make sure that every app was directly accessible from the web. So something like feature-1234.demo.cloudposse.org. We also wanted it to not be relegated to a few specific individuals who are comfortable on the command line. We wanted it to be open to pretty much anyone with permission to deploy. That means designers, front-end developers, and back-end developers as well. So that's why we had this requirement of no console access required. We also needed it, of course, to be GitOps friendly, basically Git as the system of record. We wanted everything to be stored on our GitHub and all of our releases pinned to specific point releases, not pinned to latest, something very specific so we have stable environments. So this is why we think this solution is really intriguing. Obviously, we can use it for all the standard use cases like integration tests and generally awesome QA, but where it really shines is the ability to prototype new features. For example, imagine your company is going to have a hackathon this weekend and you need to have 10 different environments for 10 different teams. You want to spin those environments up really quickly, and you want those integrated to CI/CD so that they can push their changes quickly and share them with the rest. Similarly, perhaps you have an epic that you're working on that might take a couple weeks or a few weeks to complete. You're involving lots of different team members from the front-end developers, back-end developers, and designers. And they need to be able to push changes on a feature that you're working on without destabilizing perhaps your pre-production staging environment. So these are maybe features that can take weeks or months. So you still need a place to show them. Another very real use case in use today by one of our customers is the ability for sales teams to demo features. So in this case, it's an enterprise SaaS software. And what the sales team wants to do is spin up a complete environment and stage a certain data set on there so that the demo looks really good for that customer based on the market or demographic that they're in. So these are the ways that it really stands out. Our solution is not really that novel. It's using the standard pipeline that you're familiar with and the standard workflows. So we're using the standard Git workflow with branches and tags to keep code isolated. And currently, we only support GitHub since that's just where all of our customers are. Then we integrated that with the Codefresh CI/CD pipeline. We looked into using a lot of different other CI platforms, and internally we have competency on Circle CI, Travis CI, and Jenkins. But what really stood out to us about Codefresh in this case was its tight integration with all the tools that we needed, specifically Helm, Docker, and Kubernetes. So I'll tell you a little bit more about what those technologies are as we move along. So we have this pipeline now, and it's building Helm packages that are pinned at specific releases of Docker containers. Now, for the uninitiated, Helm is a package manager for Kubernetes. And if you're familiar with other package managers like NPM or apt for Debian and Ubuntu, or RPM for Red Hat and CentOS, Helm is like that, but it's really different when you think about it, because all these other package managers, they're concerned about deploying a single package or a single application on a single host. So when you install Apache, for example, it installs it on a single host. Well, Helm is a way to package architectures together into immutable artifacts that you can then store in a registry. That is, you can package the architecture for a cloud-native, scalable application as code. So then we have these containers. These are Docker containers I'm talking about, and those have been built and tagged with a semantic versioning scheme that we've come up with, and I'm going to show you more details of what that looks like shortly. I just got a poll here. So we have now these Helm packages, and they're pinned at containers. This is a very opinionated approach that we're taking at Cloud Posse, and why that is if you know how Helm works, Helm lets you really deploy any image or any container for a given Helm chart. Helm charts are what you call the packages. What we didn't like about that solution is that it's really difficult to figure out which Helm charts are compatible with which containers. So instead, we eliminate the calculus of that decision making and instead just pin them together as immutable artifacts that are stored in a registry, and there we have it. We don't, a few months from now, we won't know which packages are compatible with which containers. Then
so
now
Eric,
yeah.
Sorry, just to interrupt really quick. We ran that poll and it looked like about half the audience hasn't heard of Helm before. So maybe just to introduce Helm to the audience, Helm is and I think you did a great job, Helm is a package manager for microservices for Kubernetes. So if you're going to deploy WordPress, for instance, which has a PHP service, a MariaDB, you can actually create a Helm package that says, so you can basically say, I want to install the WordPress Helm package, and it will deploy all of those containers onto Kubernetes. So go ahead and take it away.
Exactly. So that's a really good use case that he brought up, deploying a package that many people are familiar with. So what we're doing is now taking our custom application, our proprietary application, and bundling this as a private package. And then we can deploy that package on Kubernetes, and it builds out the entire architecture with load balancers, EBS volumes, replica sets, and it sets up like the service discovery between them, so services can talk to each other by simply using DNS. And since we deploy this in a namespace in Kubernetes, that means we can keep all those resources totally isolated. We can set resource quotas on that namespace so that it doesn't take out the rest of the cluster if it uses too much memory or CPU. And then when we want to destroy that temporary namespace, we can just click delete, and all those resources are deleted. So namespaces are a native concept of Kubernetes. Another concept of Kubernetes are ingresses, which are basically the way to route traffic between services in your cluster. This is like layer 7 HTTP routing. So send this path and this host to this service. One of the cool things with Ingress on Kubernetes is you can actually have automatic DNS supported with that. So your service, when it gets deployed, can say, hey, I want to be associated with this DNS name, and now it's publicly accessible. So for the purpose of this demo, we've taken this Weaveworks Socks Shop demo, which is a really awesome demo because it represents what a typical customer stack looks like these days. And as you see here, we can access that through the web just by going to a URL like this. This is the architecture for the Socks Shop. Basically, there's a very thin Node.js front end, and it's backed by a number of Go backing services, as well as databases. For the purpose of this demo, it would take too long to deploy all of this, so we're deploying a small fraction of it, which includes the front end, the catalog, and the catalog database. What we're going to show is now how we can take literally any feature branch and deploy that to a Kubernetes namespace that looks like this, and then we can access that on the web just like that. Not only that, we're going to show that you can now set a git commit status requirement that the staging environment is operational. And what's cool about that is in the git status, just like you're familiar with other CI systems where you can click the details link to get to the build log or the build history. In this case, you can click on that details link and it takes you straight to the staging environment for QA purposes. Then when that environment is operational, you can see the check mark turns to green, and now this branch is mergeable, assuming code reviews are approved. The other neat thing is once that environment is operational, we send a Slack notification automatically to the QA team so that they know that this feature is ready for QA. What is a unique feature to Codefresh is their massive badging system that they just came out with. I'm sure you're all familiar with similar badges like the ones in the lower right corner. Codefresh has one of those as well, but they don't convey that much information. One of the common requests is like, what's running, has master been deployed yet? Or what version has been deployed? And in this case, that's what this badge here shows. It shows that it was deployed, in this case, 2 weeks ago, and the chart that was deployed was version 0.3.12, and it was using the master branch for that chart. So now we've reached the most exciting part. We're going to do the live demo and show you this whole process in action from start to finish. Basically, what I'm going to do is squash a bug, show the pipeline executing, and then trash that environment so we can free up those resources. Okay, so first thing is the QA team has reported that there's a bug currently in the master branch. And we're going to go here to the master environment. And it pulls up and it looks pretty good, but they reported that the images aren't working down here. And I have a pretty good idea why they stopped working. It's probably related to a feature that I just did or some PR I just merged a couple days ago. So we're going to go ahead and try and first replicate this behavior on our cluster. And we'll do that simply by deploying one of these pipelines here. So what we can see here are a bunch of pipelines that we've pre-configured in Codefresh. These are integrated, these are actually configured on GitHub, so the build manifest is on there. And there's a few ways we can do this now. So the first thing I could do is I could just open up a new branch with a specific branch name, something that begins with the keyword of feature dash and then a number. And that will automatically then get deployed to a namespace in Kubernetes called feature dash that number. So like feature dash 2000 or feature dash 2001. And our thinking for this is kind of that represents your JIRA ticket or the epic that you're working on. The other way you can do it is through the Codefresh UI, and this is kind of like at the push of the button kind of deployment that I wanted to demonstrate. And now there are two ways we can do that. One is we can deploy the demo front end here, and the demo front end is an umbrella chart, and that umbrella chart includes as a dependency the demo catalog, and then the demo catalog includes as a dependency the demo catalog database. So by installing just this one chart, we're able to deploy the entire architecture. However, this is really only useful if you just want to maybe go back to a point in time and release some software and see how it worked. Maybe, did we have this bug 3 releases ago? But it's not maybe the most useful thing if you wanted to then iterate on one of these 3 components. For example, if we deployed that umbrella chart of the front end with all the backing services, and we just wanted to iterate on the catalog, it would be difficult to do because Helm doesn't let you easily replace one of your Helm chart dependencies. So for that reason, when we want to do development work, what we actually do is we deploy all the services individually that we want to have as part of our environment. All right, so I'm going to kick this off right now. It's going to take a couple of minutes. What I'm going to do is, first of all, delete this flag here. This flag basically says don't deploy the dependencies. In this case, we want to deploy all the dependencies. I'm going to add an environment variable, and it's going to be the feature. So for this, it's going to be feature, let's say 4009. And this is basically saying deploy this full stack into a Kubernetes namespace called feature 4009. And I'm going to click build, and that kicks off the pipeline. What we're waiting for now is it to complete all of these steps, and I'm not going to sit here and wait for them to complete. Instead, I'm going to show you roughly what this pipeline does, and then we're going to get a Slack notification that we're ready to go QA this environment. So this is the pipeline. First step, build that Docker image. Pretty straightforward. It's very easy because Codefresh natively understands what it means to build a Docker image. Unlike other systems like Circle or Travis, where you actually have to write the Docker commands to build that image, Codefresh has kind of turned that into a YAML representation of the same process. So it's as code. So we build that Docker image, then we generate those semantic versions. I'm going to show you exactly what those semantic versions look like in a second. We build the Helm charts pinned at those versions. We tag all of our Docker images with those same versions so that there's one-to-one correspondence between a Helm chart and a Docker image. We push those to the Codefresh Docker registry so we don't pollute our main production registry. You can use any Docker registry you want. We just prefer right now to use the registry provided by Codefresh. Then we update the GitHub status link that basically says, hey, this environment is currently being deployed. It's not yet ready. We go ahead and deploy that environment. If that's successful, we then change the status to success. So that link now takes you straight to the environment. And we notify the QA team that this feature is now available for review. So when I say generate versions, this is exactly what I mean. Oh, look at that. We just got the notice that that environment has been deployed. I'll show you what that looks like in Slack in a moment. But for right now, I'm just going to continue here explaining what I mean by versions. So semantic versioning consists of these 3 octets, basically. But the ones that most people are concerned about are the major and the minor release here. We don't modify these versions at all. These are up to the Helm chart to define, and these are based on semantics, right, of how your organization wants to advance a particular release. But the reality is that a version exists multiple times. The same exact version can exist in multiple states at the same time. Basically, I could be working on version 0.3.12 on a branch, and somebody else could be doing the same thing. So we kind of developed this scheme of disambiguating a release by including the Helm chart version and the branch and the Git SHA, either the short or the long. And you could see that in master, this would look like something 0.3.12 dash master or 0.3.12 dash master dash some SHA. So you can get very precise on the version pinning depending on the level of specificity you need. Then we generate all the charts, the artifacts of a Helm chart. These include all of the dependencies to spin up this environment in Kubernetes. It is immutable, and there are no external dependencies. They're all packaged and bundled in this tarball that you see. Then we deploy that tarball onto the cluster. So now I can navigate back to Slack here, and here is the notification that feature 4009 was just deployed. So I'm going to click on this link. This is kind of what the QA team would be doing. And here we have the environment up and running. I want to see that we reproduce the problem, and we have. We see that the problem of the missing images is still present. This is not something wrong with that environment. Let's go ahead and try and fix that. So, before this, I've set up another environment here, which is feature 4001. And you can see this also still has the problem here. And what I did when I did that was I deployed each of those pipelines independently. I did not use an umbrella chart. So like I said, remember how Kubernetes or how Codefresh is tightly integrated with Docker and Kubernetes and Helm. So now if I go to Helm releases here, I've narrowed this to the current cluster that we're using. And we can see here was the Helm chart we just deployed. And here are the two charts I'd independently deployed just before this demo. If I click on services here, we'll see that when I expand this when I expand what is it, feature 4001. Well, looks like I actually need to go deploy those other services. So you guys get the full length demo today, but I'm going to show you, here is the demo we just deployed, and this includes the catalog, this includes the front end, and the MySQL database that the catalog uses. All right, so let's kick off some builds. We're going to have some fun here. So I'm going to deploy the catalog service now to a new namespace independently. So feature, and this is going to be feature dash 4010, let's say. Save that and deploy that. So now I'm only deploying the catalog service. The rest of the site is not going to work. But since we want the front end as well, I'm going to deploy that too. So I'm going to go here to the front end, and I'm going to deploy that as well. But this time, we don't want to deploy the umbrella, the dependencies. So I have that disabled. And I'm going to add a variable that says feature 4010. So basically, I'm going to deploy the front end now to the same namespace so that we have both the front end and the catalog service and the catalog dependencies running. And I'm going to click build. All right, so under builds, we should start to see these here kicking off. Here are these two build processes going off concurrently on Codefresh. If you're familiar with Travis or Circle, you'll recognize this interface quite a lot, because you still have all the scrolling of the outputs here, but you also have a really nice nuance here, and that's that each one of these build steps is really just a Docker container. So that we have a Docker container that executes this, and we have a Docker container that executes this. So now I'm going to show what this pipeline actually looks like. And this is the pipeline. The source of truth for the pipeline you see is really in our Git repository over here. So if I navigate to demo catalog, we'll see a Codefresh YAML file. That's right here. But what's nice about Codefresh is it surfaces that build file right here. So when we want to inspect or debug things or do webinars like today, it's really easy. So Dan, do you want to point out a few of the nuances here about the Codefresh YAML?
Yeah, so just one of the things I wanted to point out here, and it's kind of important to know, in the Codefresh YAML, where we're actually defining the Codefresh pipeline, every single step here actually runs in its own container, and they're all connected by a single data volume. So what that means is that you get excellent isolation. So if you want to run different versions of, let's say, Java in different steps, or Node in different steps, you can do that. And it also makes it very easy to pass information between stages of the pipeline. So it basically means that every single Docker image is a plugin for the Codefresh pipeline, because you can basically just call in an image, execute commands against it, throw it away, and move on to the next step, and save only the information you need. This also gives you a lot more granularity over multi-stage builds. A lot of great use cases for that, and that's what I wanted to call out. So go ahead, Erik.
All right, cool. So now I want to so now that you know basically how like it has this native step of build, which understands how to build a Docker file. You can also pass all the build args and stuff that you're familiar with if you need to. You can also set environment variables, and these environment variables persist through all steps of your pipeline. Because this runs inside of a container, in this case, we're just using a generic Alpine container. We could actually have complex logic to compute the value of what an environment variable needs to be. So the way this works in Codefresh is they're actually bind mounting in a binary into this Alpine container called CF export, and that's why we can just use the base Alpine image. But Cloud Posse has developed a couple other interesting images here. Notably is the build harness. And the build harness contains logic for how we generate our semantic versions, and also for how we can send the branch protection. So we protect a branch if it's master, how we set the status of our deployment, that we're deploying changes, and then ultimately how we send our beautiful Slack notifications here using our Slack notifier. All of these are open source on our GitHub, written in Go, and very easy to incorporate in your build environment. All right, so while Dan was talking there, I saw we got a couple notifications here. Here we see 4010 was deployed. The reason why we got two notifications is we got one notification when the catalog was deployed and one notification when the front end was deployed. So I'm going to load this up. Here we go. We see the sock shop. We see that the images are still broken. Now it's time to fix this bug. So I'm going to go over here to my terminal. Here are those repositories. I suspect the problem is related to a bug that we introduced last week here. It has to do with our chart configuration. So first thing I'm going to do is check out a new branch. We'll call this feature dash 4010 dash fix images. So what this says is deploy to the feature 4010 namespace our branch where we fix images. And I'm going to make the fix. So that is in chart values. The values file in Helm defines sane defaults for everything you need. So for example, it defines the repository that this image should get pulled from. It defines the tag, and it defines the configuration. I need to point out something here that is a little bit non-conventional. One thing that we do with our templates is we use Golang templating or Gauntlet to render our values file. And this is how we get the semantic version injected into this file. So the bug here is basically we shouldn't make this relative. We really wanted an absolute path. So okay, commit -a message fix images for demo git push origin feature 4010 fix images. So this pushes this up to GitHub, which in turn then kicks off a pipeline. So I'm going to log over here to Codefresh again, go to builds, and here we see this process executing for us. So this is going to take a little bit of time to execute, and I'm going to go ahead and go back to the slides. And when we get that notification that this environment is up and running, I'm going to go show it to you that the images are now fixed. So we start here. All right. So what we've shown you is totally functional today and in use with a couple customer sites, and we're constantly deploying this with future clients. What we still want to do is some more automation, specifically around the ability to destroy environments. So what I'd like to see is when we delete a branch, that this environment is automatically destroyed, or perhaps, or similarly speaking, when a pull request is merged, that the staging environment is automatically destroyed. So for right now, you manually click that button, or perhaps the QA team creates a ticket that says, hey, this environment is done with QA, or changes the status or something like that, so that now it's very clear that we can destroy it. So I'm going to show you kind of how easy that is. So if I go over to Codefresh, I'm going to delete one of our disposable environments here. So earlier we created this environment feature 4009 to just replicate the environment, replicate the bug. So I'm going to click delete. I'm going to purge that. Purging just means that, so in Helm there's this concept that a name that you deploy is reserved, so that nobody can squat names essentially, or that you don't accidentally deploy a service into a name that was already previously used for some other purpose. In this case, we really don't care, so I'm just going to purge it and delete it, so it's good, it's gone for good. All right, let's see here. Going back to the demo. So the inspiration for all of this came from an app that was built for Heroku. It was called Forchetti, and it was one of our customers that actually turned me on to this. And the concept is review apps. So Forchetti was the very first review app that made it easy for you to deploy any single microservice to Kubernetes, to Heroku for every single pull request. However, it didn't really incorporate the ability to deploy a full environment. And that's why what we have is so much more powerful, because you can truly deploy all your microservices. So that was deprecated. And then ultimately, Heroku came out with their own implementation of this called Heroku Review Apps. And it still has the same limitation that you're basically deploying a single service at a time. Also, as promised, here are all the links, and you're going to get a copy of the slides later, so you don't have to really worry about this too much. But these are all the tools that we had to build to accomplish this demo. Basically, we have our Slack notifier, so we can send these very comprehensive and beautiful Slack notifications. We have our GitHub status updater. This is how we can interface with the GitHub status API. Oh, look, our environment is up and running. I'll jump over to that once we're done with these slides here. We have the GitHub status updater. This is how we can prevent pull requests from getting merged unless the status checks fail, succeed for a given Helm chart. Then we have the build harness. This is something we've been working on for a couple of years now. This is basically our ultimate makefile repo. It contains makefiles for building Helm charts, for building Docker containers, Go apps, and doing our semantic versioning. Again, highly opinionated. This is just how we're doing things. We have then our CF plugin, stands for Codefresh plugin. So since every step in the pipeline is really just a container, this here is our Codefresh plugin for deploying Helm charts. It's based on the one by Codefresh, but we modified it to work with private repos the way we wanted to work with private repos. Basically, so we can refer to a repo by name rather than by URL. And this allows us to keep secrets private. The other thing we are using is the chart museum for storing all of your charts. Basically, this is the API that Helm uses to download Helm charts and install them on your cluster. Chart Museum is now officially a project of Codefresh. I believe the original developer author of that has now joined Codefresh, but we are also a very big contributor to the Helm charts for installing that. So let's jump over here and show you that this environment is working. Here, 4010. And give me images. We got images. So we fixed the bug. We showed you the full life cycle of making changes in this environment, and we have success. So that is it for this demo. We're going to turn it over to Q&A shortly. I encourage everyone who is interested in this and wants to learn if their environment is compatible to schedule some time with us at Cloud Posse. Our calendar is wide open at calendly.com/cloudposse, or you can send us an email simply at hello@cloudposse.com. Codefresh has been nice enough to give us a discount code. If you enter the code of Cloud Posse, you'll get 15% off your first 3 months. Also, when you sign up, you'll get instructions for how you can score some free Google Compute credits for GKE, basically so you can run an environment like this on your own for free. I think the credit is about $500. So that's it for now. I'm going to turn it over to Dan, who will let us know if we have any questions.
Yeah, thank you so much, Erik. So Dan Garfield, who's our full stack engineer and VP of marketing, will facilitate some of your questions now. So if you have any last questions, make sure and get them into the chat box.
Okay,
Thanks, Dan.
so we actually, yeah, thank you. We've actually got quite a few questions here. So one of the first questions, and I thought this would be a good one to take for you, Erik. The question was, and I'll read it. Let's see if I can just read it. He says, we're using schemas as the database for each microservice. All of these schemas are in the prod database. How can we replicate an environment having this huge database with many schemas? Do you have a recommendation there?
Yeah, totally do. Great question. Glad you asked. So a couple thoughts here. So in production, I wouldn't recommend running, for example, Postgres or MySQL or something like that in Kubernetes, just because solutions like RDS or Aurora are so much better. However, you don't need that level of performance or reliability for your staging environments that are totally disposable. So instead, what I recommend you do is you run MySQL or Postgres as a chart, as a service under Kubernetes, and as a dependency for your application. To your point, you have a large data set in this service that you can't easily restore that, like using a dump or something like that. So we have a solution for that as well, and it's pretty easy. So when you launch or provision a new service under Kubernetes like MySQL, you have the opportunity to have a backing store like a EBS volume. When you provision that, Kubernetes allows you to pinpoint that to a snapshot ID. So long as you have snapshot IDs that are relatively current for all of your microservices, you can now restore all your databases and stuff from a recent snapshot and have it up and running. How you create all those snapshots for this, that's kind of out of scope, but that would probably be a separate process that you have running somewhere.
Yeah, good answer. Okay. The next question was, does deleting a Helm release destroy the environment? No, that it destroys the Helm release and what's been deployed. It doesn't delete the namespace. So you would want to do that as an additional step, probably.
Yeah. So that is a good point. So you'll have a few artifacts left over. When you delete a Helm release, like Dan said, there's still the namespace, and that's because you could technically deploy a lot of releases to the same namespace. So yeah, so maybe some garbage collection would be another thing we should add to that list of things for the future. Thank you.
Yeah, next question was, does Codefresh currently have an API that we could code something that would delete a service or chart on an event like branch deletion? So I'll take that one. Yeah, what you would do is in a similar way that we have a pipeline set up to automatically create the environment, you would have a pipeline set up to automatically delete an environment. And then you can run custom webhooks on anything. I mean, you can manually run the custom webhook to trigger that pipeline that would go and dispose of that environment. So that might be something for a future demo as well, Eric.
Yeah. Yeah, because I mean, I could conceive of a lot of ways you might want to delete it. You might not want to delete it until like the ticket is closed or things like that. So yeah.
Yeah. Another question was, this assumes you're running Kubernetes already, right? It doesn't bring up Kubernetes from the ground up.
Yeah, it does not address that. There's anything that seems too good to be true likely is. So a couple things. If you are running on Kubernetes today, it's going to be a lot easier. If you're not running yet on Kubernetes, don't fret. Pretty much, I haven't seen anything that won't run on Kubernetes yet. There might be other things, there might be other ways you want to run it instead, but pretty much everything will run. However, there are a couple requirements. You need to make sure that your apps are totally 12-factor compliant. That is, no hard-coded stages, no hard-coded URLs. Everything needs to be consumed. All configuration settings need to be consumed from environment variables, and then this works.
Yeah, I would add that this this particular flow that Eric set up let's see, what did you use for your DNS update? Is that Route 53?
Yeah. So we're using Route 53. So I can actually show you what that looks like. While if you want to talk about something else while I pull that up.
Well, yeah, if you want to pull it up. So I was just going to say everything here that we've shown is Kubernetes generic and will work with any Kubernetes cluster, regardless of whether you have it self-hosted on bare metal or if you have it in GKE or Amazon or Microsoft or whatever. It doesn't matter. The only things that become specific here are like the update DNS step, which in this case uses Route 53. You can have this automatically update any other DNS. There's just here you have actually a built-in step for doing it.
So getting back to Dan's question or the thing that Dan raised here, how we do DNS, we have an annotation that we add dynamically to the configuration that we use to deploy the ingress. We're still using Kubernetes Route 53, which is an older implementation. Today, external DNS is the de facto standard, but basically you specify the domain name here for your ingress host at that point. However, in the interest of full disclosure, because this is slower, we also, for demos, have a wildcard DNS set up just so the DNS is immediately available, but this DNS kicks in after a few minutes.
Yeah, good question. Okay, someone asked, we're using GitLab for source control. Is Codefresh, can Codefresh support that? Yes, Codefresh has support out of the box for GitHub, Bitbucket, and GitLab. And then if you're using the on-prem versions, then those things are supported by our enterprise plan. There was also just a side note here. Eric has his Calendly for you to schedule a consultation with him. If you have questions about a Codefresh demo specifically, you can go to codefresh.io and hit request a demo or contact sales, and we'd be happy to give you a demo. There was another question from Aaron on, is there support for Windows containers? Which I can take that question. Not today. What I should say is that the normal codefresh.io web.com experience doesn't have support for Windows today. However, it is a more or less non-trivial task. It's a fairly trivial task if you're on an enterprise plan to bring in Windows. So if that's something that you're interested in doing, we can talk about that. Here's another question about Helm specifically. It says, what is the recommended way to create charts like the one for one service, even though complete application has multiple microservices? Should I create multiple charts or just one giant chart for the whole app? So this is sort of the chart of charts or single chart kind of question.
Yeah, well, it's a chart of charts question, but it's also kind of another question I think he's asking, which is, do you have a single repo for all your charts, or do you co-tenant the charts with the microservice itself? And there's no right or wrong answer. Our approach is that we co-tenant our charts together with the service that they are responsible for managing. And the reason why we do that is it's almost always important to pair any changes that you do to the code with the chart. So if you add a new input parameter for the environment, that needs to be reflected in the Helm chart. So we like to pair those things together. Now, philosophically, do you use an umbrella chart with dependencies, or do you deploy each one individually? It kind of depends on what you want to achieve. I would say the safest bet is to keep them separate. Basically, it's much harder to replace an individual component of an umbrella chart than having each chart deployed separately and individually. And then it's easier to rev and do releases on those and not have them coupled to the parent umbrella chart.
Let's see. A couple of people are asking about the video and the recording. It will be made available. You'll get an email with that, and the QA is going to be actually included in that video. So you'll get the whole enchilada, as well as the slides, the links to the repositories, the example configurations. There were a couple of questions about looking at a Helm chart. I think we'll just include that in the links here, so that you'll get a copy of those. One of the questions here, and this is a great question that I actually hear pretty commonly, is this one's from Vera, is having a cluster per environment or using namespace per each environment recommended for production level applications?
Yeah, no, great question. This is good because we recommend at least 2 clusters, and we recommend that because you need to have a safe, risk-free environment to play around and break things. And you want to give that environment to your developers so they can do whatever they want. Then you want a separate cluster for your production infrastructure. Not only that, you're going to want to stick your staging cluster in a separate physical AWS account, and you're going to want to stick your production cluster in a different account. That way they share nothing, and then you have a way to stage infrastructure changes between your staging environment and your production environment. So, and then within your staging cluster, you can use multiple namespaces for all these things. Same thing within production. You can have multiple production grade apps running on your production cluster in different namespaces. But yeah, you shouldn't multi-purpose your production cluster for staging as well, in my opinion.
Yeah, I agree. Sorry, you said don't use multi-cluster, right? That's what I heard. Well, for production.
Yeah.
A different cluster for staging and development than for production, but yes. I would keep one production cluster in general. And that's not to say that it can't be multi-cloud, because you can have a Kubernetes cluster that has nodes on Amazon and Google and Azure and your home. I mean, you can do cloud spanning clusters like that. So I think that's a good move. Another question, will anything run on Kubernetes? Do traditional .NET, not .NET Core apps run okay in containers?
All right.
So, well, let me intro that. .NET traditional requires Windows, right? So you have to have Windows containers. Now there is beta level support for Windows on Kubernetes as of version 1.9. That's fairly recent. So there are people that are trying it out right now. I can't speak personally to say if it's ready for production or not. Do you have anything to add to that, Erik?
Yeah, let me add a qualifier there to what I said earlier. Anything that already runs on Linux, we're pretty sure we can get it to run under Kubernetes. There are so many primitives out there to replicate traditionally hosted environments, static environments, auto-scaling environments, all of that under Kubernetes. That's why pretty much everything will run. Now, if we're getting into the Windows space or using other operating systems, I don't have experience with that personally.
Let's see, and then there was a question, where do you see pod status? So this is actually in the Codefresh UI, Erik, if you want to jump over to the Kubernetes dashboard. you can actually click on an individual service here. You can see the status button, the little green dot. Click on that green dot, and this will actually show you just that all of these statuses are running properly, and you can see the number of replicas for each one. Most of these replica sets only have one pod per replica, so it doesn't show you specific pods, but it's a similar kind of thing. Let's see. You know, I'm actually happy to continue to ask questions. Most people are still hanging out to listen to the discussion, so
yeah,
I'm happy to keep going if you are. This person, this is Evans, asks, if you have multiple versions of a microservice in a given namespace and you want to test the interaction between the different microservices, do you have any recommendations to control the routing to the end-to-end microservice interaction?
Yeah, so I mean, it's a good question. Out of the box, this wouldn't really work well. You would need to further decouple basically your service from your pods. So then you can deploy the service. This is what's confusing. So in Kubernetes, service actually means like load balancer. It doesn't mean like your pods or your containers. So if you deployed your load balancer separately, now you can deploy your microservice multiple times and have that running under that, and the service will discover them. I'm not necessarily sure, you know, in terms of routing, I presume you're talking about the same service, the same microservice. So then they should be presumably under the same path. So as far as ingress is controlled, /API, for example, would go to the one particular service. I don't think you can control /API and have it go to two different services with the default Nginx ingress controller. I don't have that much experience with some of the more advanced ingress controllers out there. It might be possible, for example, with the enterprise level of Nginx or something.
Yeah, so I actually think I wouldn't, rather than trying to control this at the sort of ingress level, what I would actually do is probably spin up multiple copies with the different versions. So for instance, I can basically say, I want to deploy this Helm chart in 3 different releases that basically have 3 of its own environments to match to the 3 different target API versions that you're testing against. That would be a way of doing it that gives you maybe a little bit more isolation, and you don't run into the potential hazards of trying to manage the networking and load balancing.
Actually, I think that's a beautiful answer, and I couldn't agree more. Let me explain why I also think that's a great answer. And it fulfills another very interesting use case. Imagine you need to have multiple versions of your API available because you have a schedule at which you sunset your API. This would basically say you can deploy your API tier multiple times under multiple chart releases, and they're all still available. The one that's used is the one is based on your routing rules, which way it directs to.
Yeah. So there have been a couple of questions asking about staging and production environments, as well as is there a concept of a dev environment? Is it the same thing as staging? And then a follow-up question to that would be, when you actually go to deploy a container, do you build a new image for master branch, or do you just upgrade this container that you've just built, that's your feature branch, onto production?
Yeah, that's a really good question. The answer is both. It depends a little bit on what you want your release cycle to be, or your release engineering process to look like. Today, if you want it to be 100% Git driven, so Git as the system of record, for example, you tag a release and that goes to production. The way this is currently working, I believe it will generate new containers, but that's not a hard requirement. That's just that we haven't done the extra legwork to do that. But what you can do is you can take any one of these charts, and this is kind of like the release process that we're following right now, is that here are all the releases. no, sorry. Here are all the charts that we have. These are our internal ones and custom ones. I don't think, I guess we're currently this is not indexing the ones for the demo that we just did, but basically you can take any one of these charts and then deploy that to production. And when you do that, yes, it will use the same registry and the same Docker image and the same everything.
I'm sorry, I keep on getting distracted reading questions, and then I lose track of what you said. So sorry about that. I feel like I'm being rude, but it's facilitating. So quick question, is your underlying system based on Spinnaker? I'll answer that. No.
Yeah, some redundancy between Codefresh and Spinnaker.
My extended answer would be Spinnaker is a great tool. It actually was invented before the existence of containers in Kubernetes, and so a lot of that functionality is sort of back-ended into the system, and I'd say Codefresh is actually designed for that stuff from the get-go. So I think there are a lot of advantages if you're working with Kubernetes and Helm specifically to using Codefresh over Spinnaker.
It should also just be mentioned that I think you derive the greatest benefits by going all in to Codefresh, but nothing precludes you from continuing to use Circle or Travis and then having a webhook out to trigger a build or pipeline on Codefresh. I think that you should go all in.
Yeah, it's actually fairly common for people to come to Codefresh just trying to solve CD, and they'll use those hooks and integrations to solve the CI. Usually it's kind of an internal thing where they don't want to come in trying to replace a tool and create friction, and so they'll use it complementary. And then because you can do CI with Codefresh as well, they'll usually just end up migrating the whole thing. But this person, Ezekiel, asked, what is the best way to run Kubernetes on AWS today?
Yeah, really there's one answer, I think, and that's today Kops is still the best tool for orchestrating clusters. You have a couple other options. You have Rancher provides some nice utilities for deploying Kubernetes. CoreOS has their Tectonic release, which is built on Terraform modules. What I like about Kops is that it's a purpose-built tool that does one thing, and it does one thing very well, and that's manage Kubernetes clusters. There are a couple other things to note. Amazon has in a closed beta right now support for EKS, which is their Elastic Container Service with a K. This works a lot like ECS. Unfortunately, you got to bring your own workers, so it's not fully managed. They're only managing the control plane. And then probably by reInvent, my guess is 2018, they're going to announce Kubernetes support in their Fargate offering, which will be fully managed Kubernetes, quite like GKE.
I'm going to cross our fingers on that one. Other options, if you want to run on AWS, I agree Kops is an excellent tool. There are some services out there that will do it for you. There's a great, service called StackPoint Cloud. Also a Codefresh partner, that you can basically create an IAM. Did I say that right? You basically create your IAM service account and connect it to StackPoint Cloud, and they will create the cluster for you. They give a very GKE-like experience on Amazon, which is very nice. If you've used GKE before, of all of the Kubernetes providers, I'd say GKE, Google Cloud Kubernetes, for those that don't know, is the most straightforward, the easiest to replicate, the most full-featured. Actually, just cloud-wise, it has a lot of advantages. But if you are, if you definitely want to stay on AWS, StackPoint Cloud is a great way to create those clusters and manage them if you don't want to go through doing Kops. But I think Kops is a great solution if you don't mind getting your hands just a little dirty, not all the way dirty, just a little bit dirty.
It requires console. You have to be comfortable on the command line.
Yeah. Let's see. Opinion: how is Kubernetes in Azure ACS?
Oh, I don't have firsthand experience with Azure's container service.
I've used it. I think it works well. I think if you're in the Azure world especially, then it's a solid solution, and I recommend it. Also, we are doing a webinar in 2 weeks, Taryn, with Azure Cloud Advocate Jessica Dean, where she'll be showing how to do CI/CD using Helm and Azure. So follow us on Twitter.
Yes, that's on the 29th of this month.
Yeah, we haven't put up the registration page yet, but it'll probably be up today, maybe tomorrow. So you'll get an email about that. This question comes from Evans. He says, could you elaborate a little bit more on how you track the Docker image tag in your Helm chart versus the config value in Git? I'm not sure I understood completely what your demo previously. How does the Docker image tag get propagated into the chart definition?
Yeah. That's a good question, and this comes back to our very opinionated approach here to pinning our charts to versions. So what we're doing is when we generate let's go to the chart here. So this is the chart for the catalog. This is the values.yaml. You can see that we have actually templatized our values.yaml. Our build harness, so that's GitHub Cloud Posse build harness. When we build the package, the Helm package for this, our Helm module will basically render the templates here. So we're basically rendering these templates using environment variables and stuff like that. So there's information available to us at the time that we're running the build harness to stitch that all together. Now, when at execution time, when somebody goes to install that Helm chart, they can override that value if they want to, but by default, we're giving them something that we know should work.
Yeah, and I would also add, so I think the build harness is an excellent solution, but you can, another way of doing this is you can actually, in the Codefresh deploy Helm step, you can actually put custom values that you want to override onto the chart, and you can put your build image right there into that step, which you can then render back. So that's another way of doing it. This one, I'm going to do maybe last 2 questions here, and then we'll go ahead and close. One is there a similar solution based purely on free and open source?
You know, what I think is really beautiful about this is that every step in our pipeline that I showed you here, oh, well, it's not here, well, is a container execution. So long as your build system, let's see here, Codefresh, so long as your build system supports running a container, there's nothing saying that you have to use Codefresh for this. You could, if you can Docker run build harness and run these commands, you'll get the same output. And then you Docker run build harness with these commands. Then you do whatever your platform does for pushing images, which is probably, you know, running Docker push. So this pipeline is really like a blueprint for how to do unlimited staging environments for any deployment system. I can see this working very well in Jenkins, for example, if that's what you're using.
Yeah, there are a lot of built-in steps here that streamline it and make it easier. So you definitely spend a lot more time to go and do it kind of on your own stack like that. I always tell people if they have a few 100,000 hours in Jenkins, they can build Codefresh. I'm just not sure it's worth the time. So you can definitely do it. I've seen companies that do it and they invest quite a bit of time and resources into it. It's, I'm going to say, always more cost efficient actually to go with like a purpose-built solution that saves you all of that time and gets you that value a lot faster. And then the last question, and I apologize, we'll have to end here. If you have further questions, you can see there's a link to get a demo from Codefresh. There's a link to follow up with Erik as well if you wanted to work with him directly. And just a pitch for Cloud Posse, they do fantastic sort of DevOps as a service work where if you need help on your organization, kind of streamlining things, they actually do professional services to do that. And they use the best tools. So I can't recommend them highly enough. Last question, and then we'll end with this is, this is a sticky one. We're dealing with SOX requirements. How do you manage every change control and automate this process to avoid making the RFC for every deployment to production?
Yeah, I understand the question. Can you read it one more time just to make sure I got all the nuances?
Sure. We're dealing with SOX requirements. How do you manage every change control and automate this process to avoid making an RFC for every deployment to production?
Yeah, so that, I guess, request for change. So I don't necessarily see the problem here. As far as I'm aware, I thought having Git as your system of record and using the standard Git workflow with pull requests and code reviews and integrating that with your ticketing system satisfies that requirement. Basically, you have a change log of everything that changed, and then you have the deploy log of everything in Codefresh. So I think you would be SOC compliant there.
Yeah, and I'll just say in addition that while I actually don't have a ton of familiarity with SOX, I will say that I know that a number of Codefresh customers are SOX compliant. So might be something worth digging into to figure out how exactly they do it. But yeah, it's definitely possible, and I'll add worth it. I'll tell you a funny story, and we'll close with this. I was talking to an engineer at a company that you've used their service before. I won't name the names. And their legal team came to them and said, you know, we're worried about some of the privacy laws in Europe that are a lot of people are aware of this that have recently come out. And so we're going to need a ticket created for the legal team to review every single code change before it goes out. And he just smiled and he said, well, how many lawyers do you have? Because we have 1,500 engineers and they generally each make at least one change per day. And the legal team face kind of went, oh, well, we're gonna have to do a different process. There's definitely, my point is to say that there's definitely a way we can get it done. SOX compliant companies are doing this today, and I'm sure we can figure out what we need to do to remain in compliance. But happy to share with that in a follow-up discussion. So I think we'll go ahead and end it there. There are more questions. I apologize. We do need to end this now. Follow up with Erik. Follow up with Codefresh. We're happy to continue the conversation. The Cloud Posse code will give you the 15% off Codefresh, as well as we do have up to $500 in GKE credits when you start with Codefresh. Any other parting words, Erik or Taryn?
No, thank you guys so much for sticking through to the very end here.
Yep, thanks everyone for joining, and look out for our blog posts where you can find this presentation.
All right, thanks everybody. Have a good one.